Hello everyone, welcome to our brand new channel DevOps Inside Hub. My name is Arav and today we are diving into the exciting world of Docker and containerization. So let's start our Docker journey and break it down step by step. Alright, so Docker is like a superhero for our applications and it allows us to package our software or applications and all its dependencies into a neat little box called a container. Here, what is it? A container? So suppose using Docker, we create an Nginx container or Tomcat container. And once the container is created, what we have inside? We have an application or software that is Nginx or Tomcat and its dependencies. And with the help of these services, Nginx or Tomcat, we expose our content to outside world. Don't worry, we will do hands on it very soon. Why containers? Containers are lightweight. Containers don't require a full operating system stack, which means they share resources and it allows for faster startup times and reduced overhead compared to traditional virtualization. Also, deployment is very quick with the Docker. They are portable. Containers encapsulate an application and its dependencies, including libraries and runtime, within a single package. We call it a container image. So they are portable, means they can be easily shareable and we can use those images from anywhere. Isolated. They run independently, ensuring that what happened in one container stays in that container. This isolation means your application is more secure and less likely to interfere with each other. Also, they are platform independent. Whether it's your laptop, a server, or even in the cloud, containers run everywhere. Now, let's understand why containers are platform independent with an example. Imagine you have an app that works perfectly on your computer, but when you try to run it on another machine like server or cloud, things break. So containers solve this by making sure your app runs consistently, whether it's on your laptop or a server or in the cloud. Let's talk about the traditional server. In traditional server, first we have machine infrastructure like storage, capacity or RAM. On top of that, we have operating system. And using the operating system, we create our application, which means to create one more application, we require one more infrastructure and operating system. So more resources required in traditional server when we compare it with containerized applications. How? Let's check it out. Now, let's look at containerized application. Here we have machine infrastructure and on top of that we have operating system. Then we have Docker on it. Now using Docker containerized app A, App B, App C are sharing same operating system resources. Now, we are going to dive into the core components of Docker that make containerization so powerful. So first, let's talk about Docker client. These are the command line tools that allow us to interact with Docker, and there are three key commands we frequently use. These are Docker build. So we use this command to build Docker image from a Docker file. We will learn about Docker file in our upcoming classes. For now, just understand it is a set of instructions for creating our container environment. Then we have Docker pull. When we want to use an existing Docker image from the Docker Hub or another registry, we use Docker pull to fetch it to our local machine. If you are aware about Git or using Git, we pull scripts from GitHub to our local repository. Exactly same happened with the Docker Hub. We pull it to our local machine. Then we have Docker run. Just to create and run a container from a Docker image, we use docker run command. It can also be used to customize the container at runtime. Now we have covered the basics of Docker clients. Let's shift our focus to the Docker host. So Docker hosts consist of three main components. The first one is Docker daemon. So this is the background process that manages Docker objects like containers, network, and more. It listens from Docker API requests and manages their execution. Then we have containers. As we already learned about containers, let's check it out one more time. So containers are lightweight, standalone, and executable software packages that includes everything needed to run a piece of software, including the code, runtime, libraries, and system tools. And images. Docker images are the blueprint of containers. They contain the necessary instruction to create a container. You can think of images as a snapshot of a file system and parameter needed for running a container, which means there are so many images are already placed on Docker Hub. So whenever we require to create a container, we just pull that image from Docker Hub and create the container. Lastly, let's touch on Docker registries. So Docker registries are like libraries for Docker images. The most common one in the Docker Hub, when you Docker pull an image, you are getting it from a registry. You can also publish your own images to a registry, making them accessible to others. I hope you all understand the components of Docker architecture. Now, let's look how this architecture works. So, it operates on the client-server model. You, the user, interacts with the Docker client, which communicates with the Docker daemon. So, whenever you give the commands like docker run to create a container, docker build to create an image, or any other command. So what you are doing, you are communicating with Docker daemon using the Docker client.